Okay, so again, functions, inequality notation, and set notation. First, let's look at what a function is. Before we get to that, we have a relation, which is any relationship between two quantities. So that can be any 2 points. That's all a relationship is. A function is a relation in which every input is paired with exactly one output. So a function we can think of as a line, be a quadratic. It's something where we do not have more than one vertical point. So this could be a function, right? Something like this cannot be a function. So here we only have, for every x value, exactly one output, or one y value. Here, for every x value, say if we have a point at 1 or -1, I have not just one y value, but I have 3 y values at -1. So that is not a function. This would be a relation. This would be a relation and a function. Okay? So in my own words, a function is something for every x out, for every x input, there is only one y output. Something along those lines. Again, that's in your own words, however you want to fill it in. Examples of functions be something like this line, we would say is y equals x plus 1. Or we could say y equals, we have something like x squared. Or y equals x cubed. Y equals the absolute value of x. All of these things are functions. Okay? For every x value, I'm getting exactly one y value back out. Down below, I kind of even hinted at it. Whenever we're looking at functions graphically or relations graphically, we have what we call the vertical line test. If any vertical line crosses the graph of a relation more than once, the relation is not a function. So over here on this one, right, I said if I drew a vertical line here, I touch it 3 points. Therefore, it is a relation. However, on this one, it doesn't matter where I draw that vertical line. I'm only ever going to touch that graph one spot. Right? So that's our vertical line test. That's the easiest way whenever we're looking at something graphically to see if it is a function or not. So these could be our examples. Right? Or you can draw really anything. Right? We have a circle on our graph. Would that be a function or not? Right? If I draw a vertical line through here, do I touch more than once? Yeah, I do. So this is not a function. So that could be an example. Again, anything where we do not cross more than once. So for x squared, right, that would be our function. For x cubed, something that looks like that. For absolute value of x, something that looks like that. All of those are functions, right? If I draw a vertical line through any of these, I'm only going to touch that graph at one spot. Okay. So then let's look at some of our notations. So inequality notation is a way of writing the set of all real numbers between two endpoints. So if we look at it, it says A is less than or equal to X. It's less than or equal to B. So the X is a value between A and B. X may be A or B. And we also have A is less than X is less than B. So X is a value between A and B, but X may not be A or B. Okay. So notice the difference between these two. Less than or equal to or less than or equal to has that bar underneath saying it can be equal to that value. Otherwise, if it's just the less than, if it's just the arrow, you cannot be equal to that value. So let's do some examples of that. On just a number line, right, we just have an X number line. Say I'm going from the point -4 to 1. So the values in between are included. So our set or our domain would be from -4 is less than or equal to X is less than or equal to 1. Okay, right? -4 is included. We have a solid circle there. 1 is included. And we have all those values of X for which we can be. Okay? So that's the set of all of our X values. If we changed it and said A is less than X is less than B, I'll use those same points. -5, -4. This time I have an open circle, still shaded in between. So this time I'm going from -4 is less than X is less than 1. So notice open circle means that value is not included. Closed circle, that value is included. And of course, we can have a combination. Right? I could have open circle on -4, closed circle on 1, shade in between. So I could go from -4 is less than X is less than or equal to 1. Any combination of the such. And then we also have set notation. So set notation is a notation for a set that uses a rule to describe the properties of the elements of the set. So in this one, we have the set of X such that X is greater than 3. So, and it even tells us how it's read. So the set of all X such that X is greater than 3. So notice the difference between these two is very minimal. We're still using inequalities to do this one. Except now we just have it in these bars. So we're saying the set of all X such that, so this bar right here is such that X is greater than 3. So an example of that, again, going back to the number line. We have a greater than sign, so that's going to be our open circle. We're talking about X being greater than 3, so that means we're going to talk about the values that are above 3. So we have a set of all X such that X is greater than 3. So on our number line, we'd have an open circle at 3, shaded going to the right. We also have the opposite of that. We have the set of x such that x is less than 3. We just go the opposite direction. So again, open circle. This time our arrow is pointing to the left. We're less than 3. We're going to shade to the left. Of course, I could also write these in set notation as well. So set notation for our top one up here from the -4. We would just change what's in front of it, right? So I just say -4 plus an x less than or equal to 1. That could be my set notation. Any questions on set notation or inequality notation? Again, very, very similar. It's just set puts it in a set brackets. Okay, so now let's talk about how we're going to relate this to domain and range. So domain is the set of all possible input values of a relation or function. So in my own words, the domain is just all of my x values. How far to the left can I go? How far to the right can I go? It's kind of the way I think about it. And if domain is the set of all of our x values, our range is the set of all output values of a function or relation. So if our domain is all of our x values, our range, in my own words, is all of our y values. How far up, how far down do we go? So again, domain, left and right, it's your x values, range, down and up, it's your y values. So let's look at a couple of examples. Sketch this best. So if that's our function, or if that's our relation, we're not sure if it's a function or not. First off, let's look at our domain. So how far to the left does it go? What does this arrow mean? If I have an arrow, it's going to continue, right? It's just going to keep going forever and ever and ever. So that means our domain for this is going to go not just past -3, but it's going to keep going all the way to -infinity. So that's the most extreme, right? That arrow is going to keep going. It's never going to stop going. So we're going to go to -infinity. Now we can never catch infinity. So I'm going to say is less than x, because again, domain is our x values. How far to the right are we going to go? So we've got the arrow going to the left. We still have everything connected. Now we have an arrow going to the right. So how far to the right do we go? Infinity, right? If we're going to the left to -infinity, we're going to the right to +infinity. And again, we can't include infinity. Right? We can't ever catch it. It's just going to keep going. So we're always going to be less than signs whenever we're dealing with infinity. Our range, however, is again the set of all of our y values. So what's the lowest y value that we have on our graph? What's our lowest point? -1. So we're going from -1, our lowest value, and we touch at -1, right? We're flat there, so we're going to include that. So -1 is less than or equal to y. How high up do we go? What's our highest point? +1. So there's our range, right? We can touch -1, we touch at +1, so we're going to include those values in our set of our range, of all of our y values. And then the last thing, is this a function? Can we pass through using our vertical line test only once? Right, so if I draw a vertical line, does it matter where I draw that line? I only ever touch once, right? Vertical line here, I only touch there. Vertical line here, I only touch there. So is this a function or not? Yes, it is a function. Okay. So then let's look at our next one. So I've got So what would our domain be on this one? How far to the left do we go? If we're looking at it on our x, what's our farthest to the left that we go? You guys can look at your paper as well. -5. And this time we stop at -5, right? We have that point there. I'm going to write this one in set notation, so just so we can see it again. This is all of our x such that x is -5 is less than or equal to x. How far to the right do we go? What is it if we're on our y-axis?